Okay guys, today we're going to do the last thing you have to know how to graph in Algebra 2. So it's kind of a bittersweet thing. Nobody likes graphing, but this is going to be the last thing you will have to know how to graph. I mean, we've graphed lines, parabolas, we graphed those roots where it stopped in one place. And what we're going to be graphing today is equations where the x is actually the power, the exponent in the problem. So first, for this to really make sense, we need to briefly review what an exponent is. So 4 to the second is 4 times itself. We know that's 16. But I want to recap how negative exponents work. So we underline the problem, make another line, and 4 goes to the bottom. And the negative 2 becomes positive 2. And then we need to cover the top with a 1. Okay, so 4 to the second is 1/16. Now compare these two things, and what do you notice? They're reciprocals of each other. Okay, that's what a negative exponent does. It causes the value to reciprocate. Okay. Now, 1 to the second, so I got 1 over 2. And both those would be 1 times 2. 1 times 2, and that just ends up being 1/4. Okay, now, so it'd have 1 to the negative second, and then 2 to the negative second. But then I got to fix my negative exponents, so these have to switch places. So that's going to go to the top, and that's going to go to the bottom. So that's 4, and that's 1. Okay, so what do you notice about these answers? Oh, they're reciprocals. Once again, a negative exponent causes what you'd have as a positive exponent to reciprocate. Now, here's a strategy for graphing. There's a method to the madness here that makes it a surefire way every time. So first off, here's the x. The base is not a fraction. So if the base is just a whole number like 4 is, you're going to do inputs of the best way to do it is inputs of 2, 1, 0, negative 1, negative 2. And then I'm going to pick a final number that's kind of far out. And that number is going to be negative 10. Okay? You'll see why I did that here. So 4 to the second, 16. You should know that. 4 to the first power is 4. Now, 4 to the 0 power is not 0 because any base to the 0 power gives you 1. Okay. Now with these negatives, you're like, oh my gosh, I have to draw a line and flip it. No, you're not. You're going to put negative 1 into your calculator, so 4 to the power of negative 1. Okay, 0.25. Okay, and now do negative 2. So 4 to the power of negative 2, 0.0625. Okay, now here's what negative 10 is going to show us. Whoa. I'm not going to write all that. I'm just going to put 0.0 and then a bunch of dots here. Okay? Now, the reason why that is like that is because the further I get infinitely closer to 0. Okay? See, that's really close to 0. It practically is 0. That is what is called the asymptote, okay? And here's how to spell it. asymptote. So the asymptote is 0, okay? Now, I'm not actually going to graph this, okay? This will tell me when I do this negative 10, it'll tell me the number it gets infinitely closer to, but just never quite touches it, never quite crosses it. So let's graph this. So we got to go by 2's probably to get up to 16. Now, what you need to do first is set up your asymptote. And 0, it's always a straight horizontal line. So if the asymptote is 0, that's right in the middle. It's pretty much on the x-axis. So I'm going to trace kind of over that. All the points have to be on one side of this. Okay? So 2, 16, I go 1, 2, and then 2, 4, 6, 8, 10, 12, 14, 16. 1, 4, I go 1, 2, and then 4. 0, 1, I go halfway, because keep in mind. And then what happens is I go negative 1, and that's pretty much at 0, and that's pretty much at 0. And what I do is it forms this kind of hook shape. But remember, we said we can't cross this line. So what I do is I just pretty much hug it, put it so it like gets closer and closer, but never quite touches it. And then that one goes just higher in that direction. So it's like a fishing hook. It's like a bent fishing hook. That's what all these are going to look like. Okay, now the next one, -4 times 2 to the x power plus 2. Okay. By the way, I'm going to put my little upside down V here so I know that that's to the x power. So again, x is the power. Its base is a whole number. Okay. And I'm going to keep asking if the base is a whole number. Yeah, it is, because sooner or later you're going to get some fractions as bases. Okay, so again, 2, 1, 0, -1, -2. Let's block that off and then go to -10. Okay, so I'm going to take -4 times 2 to the power of 2 plus 2. That gives me -14. I take -4 times 2 to the power of 1, and then plus 2 to that's -6. It's really just pleasing PEMDAS. Okay, -4 times 2 to the power of 0 plus 2 is 2. Now you're like, well, I thought it was always 1. Well, no, that's 1. That is right there. But if you take 1 times -4, that's -4, and add a 2 to it, that's -2. So -2. And then I take -4 times 2 to the -1st power plus 2, and that's going to be 0. That's okay. And they're like, well, I thought you could never hit 0. Oh, but this is going to have a different asymptote. -4 times 2 to the power of -2 plus 2 is 1. And now, I'm going to plug in the -10 because that's going to tell me that number that I'll get close to but never cross. -4 times 2 to the power of -10 plus 2. What number is that really close to? I'm going to put 1.99, but it's really close to 2, okay? That's your asymptote. Now the asymptote is moved to 2, positive 2. And you're like, well, how'd that happen? Well, here I wasn't adding anything behind the exponent. Here I'm adding a 2. So that's why it's 2. Okay, so first thing, to get to 14, we'll have to go by 2s. So 2, 4, 6, 8. I actually think it helps to number these. I know nobody likes to, but for me it helps. Okay, so the asymptote's at 2, so now the asymptote shifts up here, and all numbers have to be on one side of the line. Now, this is kind of going to be different, because 2, -14, I go to 2, and then 2, 4, 6, 8, 10, 12, 14. Now they should all be on this side. 1, -6, so I go 1, 2, 4, 6. 0, -2, so I go down to 2. -1, 0, so that's right on the axis. It's an x-intercept. And then -2, 1. 1 is halfway. And again, what happens is we get infinitely closer to the positive 2 line, but you never actually cross it. Okay? That's how power works. When we have an exponential function, and you're like, well, what would that be on a story? Well, the story problems are always that the least amount of money could be 0. Okay? Okay, now, shifting gears here. Y equals parentheses 1/3 to the power of x. Now, look at x's base. It's a fraction. So when it's a fraction, I'm going to do the opposite on the x's. You see how here I was always starting with 2? Now I'm going to start with -2, -1, 0, 1, and 2. Okay? Because what it's been is, instead of 3, it's the reciprocal of 3, so I have to do what's called reciprocating my x's, have them go opposite. Okay, so I'm going to have 1/3, just put it in, to the power of -2, and that's 9, because it reciprocated it to 3 and took it to the power of 2. Okay, 1/3 to the power of -1. Again, it's going to be like 3 to the first, but it's reciprocated, okay? So 3. Okay. 1/3 to the power of 0 is 1. 1/3 to the power of 1, it's just going to be 1 and 3. It just takes those both to the first power. And then 1/3 to the power of 2. Okay, 1/9. Okay, now you're like, well, what about the asymptote? Well, now instead of -10, you're going to go to +10. Okay, so 1/3 to the +10th power. Okay, that is obviously very close to 0. So the asymptote is 0. Now, I'm not a big fan of graphing fractions, so we're going to actually divide those. So I'm going to take 1 divided by 3, 0.33. And then I'm going to take 1 divided by 9. 1 divided by 9 is 0.11. Okay, now the asymptote again is 0, so now that's just right in the middle. Asymptote's like that imaginary line that all points are on one side of. So I'm going to go by 2, so -2, 9. Again, it helps for me to number. And they're all positive, so -2, 9. I go left 2. That's a horrible asymptote line. Okay, I'm not sure why. It should go just straight across. That's like, I'm not good at drawing straight lines. I'm kind of a bumbling idiot. So -2, 9. So 1, 2, and then 9's here. I know these lines are hard to see. Just go with it. -1, 3. It's better than making you draw the graph yourself. 0, 1. 1, 0.3. And then all we do is get closer to the asymptote line. It's impossible to cross. Okay. That's why those story problems, I would always make a curve, because that's what an exponent does. Okay, now -2 times base 1/2 to the power of x minus 3. Okay, so my base is a fraction, so I want to start with the negatives before doing the positive. And then I'll do 10 for my asymptote. Again, anytime this is how any graph with x as the power or the exponent works. So -2 parentheses 1/2 to the power of -2 minus 3 is going to be -11. -2 times parentheses 1/2 to the power of -1, and then minus 3 from that, it's -7. -2 times parentheses 1/2 to the power of 0, minus 3 is going to be -5. Okay. -2 times 1/2 to the power of 1 minus 3. It's going to be -4. Now, -2 times 1/2 to the power of 2 minus 3, -3.5, so just put -3.5. I'm not a fan of graphing fractions. So now let's put a power of 10. Okay, that's going to be kind of crazy, but I'm not actually going to graph it. All that's doing is checking where the asymptote line's at. -3 and 1 over 512. Well, it's pretty much -3. Okay, so I set that at -3. And you can see it was going to be -3 because we were subtracting a 3 at the end, and that will always be our asymptote. But if there's a number that we're adding or subtracting. Now, if there's not, then it's 0. Okay, so I'm going to go asymptote's -3, but I got to have everyone worth 2 probably. So -2, -4, -6, -8, -10, -12. Okay, so -3, and that's right here. Right, kind of between them. Remember, all points have to be on one side. If you get points that cross over the line, you did it wrong. So -2, -11, I go left 2, 2, 4, 6, 8, 10, right there. negative 1, 7, 2, 4, 6, and then 7. 0, negative 5, so 2, 4, and then 5. And then 1, negative 4, so I go right 1, down 1, 2, or down 4, yeah, 4 is right here. And then 2, 3.5. See, all you do is get closer to 3, okay? Okay, next up. Y equals 2 times 1/4 to the x plus 1 power minus 7. Okay. Now I'm going to circle this plus 1 because I'll just bring that back later. Okay. I'll minus 1 to all the x's after everything's figured out. I can adjust that. So we have a fraction as the base, so I want to start with the negative exponents so they reciprocate that. Then 10 will tell me what that asymptote line's at. Okay, so 2 times 1/4 to the power of negative 2. Don't worry about the plus 1, and then go to the minus 7 from there. Okay, so we're at 25. 2 times 1/4 to the power of negative 1 minus 7 gives me 1. 2 times 1/4 to the power of 0, and then minus 7, going to give me negative 5. Notice how I'm skipping that plus 1 every time. I'll deal with that later. 2 times 1/4 to the power of 1, and minus 7. That's going to be negative 6.5, obviously negative 6.5. And then 2 times 1/4 to the power of 2 minus 7. Negative 6 7/8. So what you do is you write negative 6, put a decimal, and then divide 7 by 8. Okay, it's all you have to do. So 875. So it's 875. Okay, now let's do 10 and see what's happening there. So 2 times 1/4. It's best to pick some crazy exponent like that to see that imaginary line you can't cross. It's a good discovery. Well, that's really close to negative 7. So negative 7 must be the number we can't hit. So we're going to count by 5s. 5, 10, 15, 20, 25. And then I got to set my asymptote down at negative 7, which would be halfway in between those. Okay, so negative, oh yeah, by the way, the plus 1, you have to just minus 1. So that's going to go down to negative 3, negative 2, negative 1, 0, and 1. Okay, so negative 3, 25. I go left 1, 2, 3, and then up to 25. Negative 2, 1, I go 2, and then 1's right there pretty much because we are going by 5s, keep in mind. I go left 1, down 5, 0, down there, and then all you do is pretty much just get closer to that. It should look like a hook, okay? And you put arrows on both ends because I can pick any x I want. It's not like those square root problems where you can't put negative numbers in the square root. You can put any of the positives and negatives, and that's why the domain is not restricted. Okay, next one. Y equals negative 3 times 1/5 to the x minus 3 power plus 2. Okay, again, this time my power's x, but then there's a fraction, so I want to start with the negatives. And we'll deal with that minus 3 by plussing 3 later. 10. Okay, so I take negative 3 times 1/5 to the power of negative 2 plus 2 gives me negative 73. That's nice. Okay. Negative 3 times 1/5 to the power of negative 1, and then I add 2, and that's going to be negative 13. Negative 3 times 1/5 to the power of 0, then plus 2 is going to be negative 1. I'm expecting that because there's a 2 being added that the asymptote's going to wind up at 2, but you never know. Okay. To the power of 1 plus 2 is 1 2/5. So I put 1 point, and then you just take 2 divided by 5. It's that easy, so it's 1.4. Instead of 0.4, it's 1.4. Okay, so -3 times 1/5 to the power of 2, and then plus 2. 1 22 over 25. Well, I'm probably not going to graph 22 over 25, so I divide it into a decimal, so it's 1.88. Now, let's see what 10 does. I'm guessing it gets something really close to 2. Oh, yeah, it's really close to 2. So the asymptote's 2. Okay, so -73. Well, obviously, we're going to have to go by like 10s to hit that. Okay, asymptote up at 2, so it's pretty much just a little bit above the x right there. Okay, so -2, -73. I go left 2, down to 73. -1, -13. I go 1, and right there. 0, -1's just right here. 1, 1.4. So all you're doing is getting closer to the line. You can see that as it happens. Okay, there you go. Okay, now, again, it's very important that you pay attention here. And I screwed something up here. I'm not going to go back and do it, but I needed to add 3 to all these, okay, before I graphed it. I just realized that. So 1, 2, 3, 4, and 5. That's what I should have graphed. So it would make it move, okay. I forgot that. So you can see it happens, not a biggie. Okay, now here's the x. The base is not a fraction, so I do not start with the negatives. I start with the positives. That's important not to forget, okay? So now it'll be -10 that I use to figure out my asymptote line. Okay, so 3 times 2 to the power of 2, and then don't minus 3, just add the 4 that's there, and that's 16. 3 to the power of 1 plus 4 is going to be 7. And these don't follow a pattern, so you're going to have to do the dirty work. 3 to the 0 power, and then plus 4 gives me 5. 3 to the negative first power plus 4 gives me 4.33. 3 times 4 to the power of -2, and just plus a 4, 4.19, okay? Now, I'm expecting this is going to be close to 4, because there's a 4 being added. So 3 to the power of -10 plus 4. Okay, yeah, it's really close to 4, okay? So asymptote's going to be 4, so we can put that there. Okay, so now what I need to do then is plus 3 to all these. That's easy to forget. Try not to. I'm probably not going to have your head on a test if you do that. It's not. So 16, let's go by 2. So remember to set the asymptote. 2, 4, and I'll still be able to reach 16 that way. Okay. So 5, 16. 1, 2, 3, 4, 5. 2, 4, 6, 8, 10, 12, 14, 16. 4, 7, 1, 2, 3, 4, 2, 4, 6, 7, 3, 5, 1, 2, 3, right there, 2, 4 point, so 2, and then all you do is get closer to the 4. Okay, now I'm not going to do that last one. I'm going to turn you loose. You'd start with 2, 1, 0, -1, -2, and then -10. You'd do the same thing there because there's no fraction as the base. But on the other side, you have fractions at the base, so what you want to do is start with your negatives and then go to the positives. Okay? Not a fun thing to do. It's just a one-day thing where you have to do all these. It ain't like we practicing for 5 days.